You know that I told you, whenever you are going to cascade amplifiers, the overall gain will be product of individual gain. So AV overall will be equal to AV1 into AV2 into AV3 into AV4, etc. up to AVN. N is the number of stages. So you know each stage is identical. So all these individual values are going to be constant. AV1 low equal to AV2 low equal to AV3 low equal to AVN low. I can write. So when you multiply the same number n times, it becomes that number power n, right? So AV low overall will be AV low power n. This is because we have considered the stages to be identical. Okay. So whenever you are going to find the bandwidth, you'll be dividing it by the mid frequency, because at mid frequency only the gain is going to be constant. So AV low by AV mid equal to AV low by AV mid power n, because AV low overall is, you know, it is AV low power n. And this formula I know it is 1 by 1 minus j f1 by f the whole power n. So this is the low frequency formula which we have derived in the low frequency analysis. In the low frequency, the characteristics is going to be 1 by 1 minus j f1 by f. F1 is your lower cutoff frequency and f is the general frequency which is varying from 0 to infinity. For finding the bandwidth, what will you do? Take the modulus of this, equate it to 1 by root 2. Because it is voltage or current, if you find it is 1 by root 2, you have to equate for power, you have to equate to minus 3 dB. But since we are finding everything in terms of voltage, we are going to equate that to 1 by root 2. And take modulus for this complex number. You know, for the modulus of complex number a plus jb, a plus ib or a plus jb is root of a square plus b square. Same thing. 1 by, you see, square root of 1 plus f1 by f dash, f1 by f dash, the whole power, whole square, the whole power n is equal to 1 by root 2. So I am just inverting that. So 1 plus j, sorry, j will 1 plus f1 by f1 dash, the whole square, power minus n equal to 1 by root 2. Okay. And here also I can write this one 1 by root 2 as 2 power minus half. So in both sides I have negative power. So I can remove that and make it positive. So I can write 1 plus f1 by f1 dash the whole square power half, the whole power n is equal to 2 power half. So I can cancel this power half on both sides. So 1 plus f1 by f dash the whole square power n is equal to 2. So bring this n to other side. So 1 plus f1 by f1 dash the whole square equal to 2 power 1 by n. When you have n on this side, when you take this n to other side, it is nth square root, right? Nth power. So when you take it other side, it becomes 1 by n. So from this I can find, bring this 1 to other side. So 2 power 1 by n minus 1. Then take square root on both sides, root of 2 power 1 by n minus 1. Then find what is f1 dash equal to. So f1 dash equal to f1 divided by square root of 2 power 1 by n minus 1. This is the new cutoff frequency for the second stage. Similarly, f2 dash will be, I can find f2 dash is going to be f2 multiplied by the same factor. You can see the lower cutoff frequency is going to be increased. The upper cutoff frequency is going to be decreased. So this manner only the bandwidth and the frequency parameters are going to be decreased. Okay, and that n is going to be number of stages. So this root of 2 power 1 by n minus 1 is a factor which is common to both the frequencies f1 dash and f2 dash.